So now that we've talked about the TaskGang abstract superclass, let's talk about the first subclass that customizes it, which is called SearchTaskGangCommon. And we're going to talk about all the different subclasses, but we're going to start off with this one. And that's because it is actually the parent or the superclass of all the subsequent subclasses that extend it. And you can find this code here at this link in the SearchTaskGangCommon.java file in my GitHub repository. So this is where SearchTaskGangCommon sits in the overall framework. You can see that it extends TaskGang, and then it itself becomes the parent or the superclass for the one-shot thread per task, one-shot executor service, one-shot executor service future, and one-shot executor completion service subclasses. And basically, you can think about this as starting the customization of the TaskGang framework so it can concurrently search for keywords in a list of strings or lists of strings. And that's an important customization. TaskGang by itself knows nothing about lists of strings or keywords. It does know about input, but we're going to customize this so it works for searching strings. And this is where you can get the source code for this. So the TaskGang subclass factors out code that's common to all the different subclasses that the search TaskGang test creates. So that make TaskGang factor method in the search TaskGang test class, those are the things that it makes, and they all subclass from this particular superclass. So it does a couple interesting things. It uses an iterator to systematically access all the input. And what that does is it takes the array that's passed in and turns it into a list. You can see how it does that. It uses the arrays.asList factor method to convert the result of the input iterator into a list and gets that returned. And this particular example just has a single set of input strings. You could have cycles and have multiple lists of input strings. We just have a single list of input strings. Each task that SearchTaskGangCommon defines runs exactly the same logic. It returns the search results. So it's going to check to see how many times the word appears in the input data, if at all. And we'll take a closer look at that when we get a little further along. So that's the search results method. It's going to make a new search result object, and it's going to go and find out how many times the word appears in the input data. These tasks are embarrassingly parallel since there are no dependencies. All the lookups can take place independently of each other, which is great. It makes it really scalable. This is what a search results object looks like. It's a class that's got some information like what is the input data that's being searched, what's the word that's being searched for, what thread is this taking place in, what are the list of results, which are basically the indices into the string where the matches are occurring. And we'll take a little bit of a look at this. It's a pretty straightforward class, just basically is used to hold the results of the searches so that we can print them out later. This is where you can get the source code for this. Now, the await task done hook method shuts down the executor and then waits for the gang of threads in the pool to exit. And you can see it does this by calling the shutdown method on the executor and then calling the await termination method, which will wait for all the threads to shut down. So it's trying to do a clean shutdown. There are no commitments yet to the other hook methods that are defined by the TaskGang framework, aside from get next input and await task done. The other things are left as stuff that will take place later. In particular, there's no executor implementation, there's no concurrency model, there's no sync or async processing, there's no specific source of input string objects, etc. Those things are all going to be added later by subclasses for the search TaskGangCommon. So these are all things that have to be filled in. And these are the ways that they fill them in. You can see if you take a look at the different subclasses, they override other methods that are needed in order to be able to get the behavior for that particular concurrency and synchrony, asynchrony model. So let's go take a quick look at SearchTaskGangCommon. So here we are in the SearchTaskGangCommon class, just factoring out the code that's used by all the implementations of the TaskGang subclasses, or more specifically, the SearchTaskGangCommon subclasses. So one thing it does is it stores the array of words defined. It stores the iterator of string arrays to iterate through. It's got a constructor that essentially stores the words defined and creates an input iterator that will take the strings to search, which is a two-dimensional array, make a list of these, and then get an iterator to that. Here's what the get next input method does. As you can see here, if there's anything left to do, we increment the cycle, and then we convert the next result from the input iterator into a list, and we return null if we don't have anything else to do. Here's the await tasks done method. You can see we use the very modern Java ability to do downcasts via instance of and then define a variable here. It's kind of a neat feature, a little bit like C++ in some ways, except it's for downcasts. specifically here. And if indeed the executor is an executor service, we call the shutdown method on the executor service, and then we await the termination. We just basically wait for all the threads in the task to complete. And you'll notice we use the rethrow supplier method here to avoid having to use the horrible try catch block, which comes from the somewhat cancerous use of checked exceptions in Java. So we avoid that. Await termination requires checked exceptions. We use this rethrow supplier adapter to basically do the checking inside of the method here, and then we wrap it and convert it into a runtime exception if it occurs. And then the final things here are looking up the words themselves. You can see we have a method called search for words, which makes a new search results object, which has the thread ID, the current cycle count, the word we're searching for, and the input data we're searching the word in. And then it's got something called make results index of, which takes the word and the input data, and it returns a list of search results result objects. And this is what it does. This is a very Java 5, Java 7, older school, object-oriented Java way of doing things. It's not the cool Java Streams way of doing things or other stuff that we've talked about in other contexts, for example, using regular expressions and whatnot. What this does is it creates a results array, and then we're going to go ahead and take the word, and we're going to see if we find anything that matches in the input data. And if we get back a number that's not -1, we know we got a match. So we go ahead and we add it to the results array. The next thing we do as we go through this loop is if we do get a hit, we then start from one position down in the array and we go and do the index of call again and see if we find a match there. And this will keep going until there are no more matches left. When we're all done, we've got an array that will have a list of search results, result objects, and that gets returned back up here and stashed away into the search results constructor. And you can see all that does is just store the values in there. So that's the walkthrough of SearchTaskGangCommon, which is really kind of an intermediate class that holds the other stuff together and begins to customize the generic TaskGang framework for searching words in strings.